Today we're starting 2.1, using transformations to graph quadratic functions. The main part we're going to talk about in this part is how to graph them. We're going to talk about quadratic functions, what a parabola is, and the vertex of a parabola. When you guys took Algebra 1, you studied mostly linear functions, y equals mx plus b. But now we're talking about quadratic functions. In Chapter 1, we talked about quadratic functions being, what's the parent function for a quadratic? X squared. So quadratic starts with x squared. We're going to have it written as a times quantity of x minus h squared plus k, where a is not equal to 0. In a quadratic function, the variable is always squared. When we talked about linear functions, you don't need to put the table directly in your notes, but you need to understand what we're talking about. I have f of x equals x. That's our basic linear function. If you create a table, I could pick whatever points I wanted, substitute into the function, and you get a straight line. For quadratics, the points you pick, it matters a little bit, because when you graph a quadratic, it makes a U. The most important part, when you graph f of x equals x squared, the quadratics are U-shaped. It is called a parabola, or you can call it a parabola. Tomato, tomato. When you graph a quadratic, I have these points. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. When you plot those points, it makes a U shape. That bottom of the U is called your vertex. If you just pick random points, you're not necessarily going to have the full U shape. I'm going to show you how to do that in a little bit. Here I have the function x squared minus 4x plus 3. We're going to use a table, and then we're going to graph it. In the first column, I'm giving you x values. What we're going to do is take those x values and substitute into the function, and then get a new ordered pair. When we're filling in the table, what we're going to do is we're going to substitute in 0 for x. What this is really saying, 0 squared minus 4 times 0 plus 3. What's 0 squared? 0. What's 0 times anything? 0. So I'm just left with is 3. My coordinate is 0, 3. The 0 comes from here. The 3 is what my answer was here. The second point, I substitute in the 1. So I'm putting the 1 everywhere I see an x. 1 squared minus 4 times 1 plus 3. 1 squared is 1 squared, 1. Negative 4 times 1 is negative 4. 1 and negative 4 is negative 3, and positive 3 is 0. The point is 1, 0.
So how you get 4 still, and 4 times 0 is 0?
I didn't get 4, that's a 3 there. 0, 0, just left with a 3. By substituting 2, 2 squared minus 4 times 2 plus 3. What is 2 squared? 4. What's negative 4 times 2? Negative 8. So what's what's 4 and negative 8? Negative 4. What's negative 4 and 3? Negative 1. So my point is 2, negative 1. Substitute in 3. 3 squared minus 4 times 3 plus 3. 3 squared is 9. Negative 4 times 3, negative 12. 9 and negative 12 is negative 3. Negative 3 and positive 3 is 0. So my point is 3 comma 0.
How you get the 3 numbers?
Right here. The next one, 4 squared minus 4 times 4 plus 3. 4 squared, 16. 4 times 4 is 16. What's 16 minus 16? 0 plus 3 is 3. So my point is 4, 3. All right, when plotting our points, our first point is 0, 3. 0, 3. Our next one is 1, 0. 1, 0. The next one, 2, negative 1. 2, negative 1. The next one is 3, 0. And our last one is 4, 3. Now, notice the points I gave you make a perfect U. I could take and draw a U through here. It's not a V, it's technically a U. The V we'll get to later on in the year. There's your U. It is a parabola. And it's faced upwards. Why is it faced upwards?
It is quadratic.
Last chapter we talked about parent functions. What's the parent function here? The parent function is, whoops, don't have a marker, is x squared. So if I have x squared, only thing about it, it's positive. Positive means it goes up. If it was negative, it would reflect down. Because in chapter 1 we talked about reflections making it negative. Here's a different one. Negative x squared plus 6x minus 8. Now I give you points here that will make it nice. The one thing you need to be careful of, negative 1 squared is not equal to negative 1 squared. These are two different things. Here, I'll put x's here. If you give me a number. Give me a number. 5. What's negative 5 squared? Negative 25. Because it was negative whatever 5 squared is. This one is saying negative 5 times negative 5, which is 25. They're not the same. And the calculator does not know the difference. Even if you type it in the calculator, if you type it in incorrectly, it will give you whatever you typed in. So here, if I look here at x squared, this actually means negative 1 squared when I'm doing the first one. What's negative 1 squared? Because it's in the problem. Negative 1 squared is 1. Now make it negative because there's a negative out front. All right, when we substitute in, we have negative 1 squared plus 6 times negative 1 minus 8. Negative 1 squared plus 6 times 1 minus 8. Whenever I'm substituting in an x, what I'm going to do is put parentheses around it. That way I know I'm not going to mess up with signs. Negative 3 squared plus 6 times 3 minus 8. Negative 5 squared plus 6 times 5 minus 8. And negative 7 squared plus 6 times 7 minus 8. Now, the math. What's negative 1 squared? Negative 1 squared is 1. Now we make it negative 1. 6 times negative 1, negative 6. Negative 6 and a negative 1 is negative 7. Negative 7 and negative 8, negative 15. So your point is negative 1, negative 15. The next one. 1 squared is 1. Make it negative. What's 6 times 1? 6. What's negative 1 and 6? 5. What's 5 minus 8? 1, negative 3. Three squared, 9, so I put negative 9. 6 times 3, 18. Negative 9 and 18 is 9. 9 minus 8 is 1. 5 squared is 25, so you make negative 25. 6 times 5 is 30. Negative 25 and 30 is 5. 5 minus 8 is negative 3. 7 squared is 49. Make it negative 49. 6 times 7 is 42. Negative 49 plus 42. So you want to spend $49 and you have 42. You don't have enough, you need 7 more. Negative 7 and negative 8 is negative 15. What do you notice about these points? They're flipped. They're symmetrical of one another. You can tell just by looking at these. This one right here is the one center point. Then these two mirror each other, these two mirror each other. When you pick numbers, it doesn't always happen like this. I picked numbers up here so it would do that. If I graph these now, what's the first one? Negative 1, negative 15, which is down here. The next one? 1, negative 3. The next one? 3, 1. 5, negative 3. And second, negative 15. If you look here, that's close enough. The parabola is upside down. The reason why this one is upside down, because it's this right here is a negative x squared. The parent function is negative, so it flips it. If I picked all positive numbers, sometimes it might all be on one side. If you graphed it, it might look like this. Sometimes you might only pick all negatives, so it might be on one side. When I just randomly pick numbers right now, what I would do is a couple negatives, pick 0, pick a couple positives, and see if you can determine the shape. Any questions?